And Triola talks about next the mean absolute deviation. And this is not an algebraic manipulation, and it is biased. So I'm not going to discuss that, but if you are using the Triola book, you may want to do a little bit of reading about the mean absolute deviation. So the next thing that I'm going to talk about is something called the coefficient of variation. And the coefficient of variation is a good way of taking a look at how two data sets can be compared to one another. And these two data sets can be compared by a percentage value that's according to their standard deviation and their their means, and then can put in terms of a percentage. So it becomes a unitless measure and then allows for direct comparison because you're talking about apples to apples rather than two distinct types of two different numbers from two different populations. So if there's a reason to compare them, you can actually compare them legitimately. And I'm going to pause right now and see where I'm at in terms of time and see if maybe I want to go ahead and start a new video. Okay, so let's do this quickly, the coefficient of variation. So if we have these two sets of data, one for ATM fees in New York and one in LA, what we first want to do is do some basic computational statistics to find the sample mean for LA and the sample mean for New York City, and some basic computational statistics to find the standard deviation for LA and the standard deviation for New York City. You see I've written all of this work out. This is my expectation for my students at this point in time, so this is the minimum that you would need to show in order to show me that you have found the mean and the standard deviation. Now we also learned to find these using our calculator. At this point in time, your calculator would be a check for you, and later on it'll be the only way that you'd find these. You wouldn't have to write a formula out for me, but right now in my classes I do require that this amount of work be shown in order to show means and standard deviations. Now once we get these calculations made, then we're going to create the coefficient of variation. Our coefficient of variation is the standard deviation. Now we're dealing with samples, so all we have is standard deviation of the sample. So LA's standard deviation rounded to the nearest tenth of a cent is 678, and our mean for LA is rounded nearest cent is 1438, and then we're going to multiply that ratio by 100 to change it into a percent. So if I take 0.678 and I divide it by 1.438, I will get 47.1% approximately, and I only need to the nearest tenth of a percent. That's the typical rounding place for percentages. So this is 47.1% variation. And then for New York City, the same thing. Take the standard deviation in New York City, 47.7 cents, and the mean $1.63, and I will compute that coefficient of variation. So 0.44477 divided by 1.063 and multiplying that by 100%, I get the coefficient of variation here to the nearest tenth is 44.9%. So what we see here is the variation in LA is much higher than the variation in New York City. Now just a general perusal of that kind of reveals that in the data itself, but that's not always quite as evident as you might think. We may be dealing with a lot more data and a lot more variation in the data, and it may be hard for us to tell that. So these two numbers in comparison and side by side, we see that the variation in the New York City data is less than the variation in LA. So you can be more certain, in other words, of what you're going to pay for an ATM fee in New York City than what you're going to pay in LA. All right, that ends this section, so I'll stop the recording right now.